All right, everybody, welcome back. Now we're going to do part 2 of our RE2 properties of exponents video for you. Thank you for coming back and watching. I'm optimistic you'll get something out of this and get the practice that you were looking for. So here in our second part of the video, we're just going to tackle the problems we didn't do in part 1. If you haven't seen part 1, please go back, watch that first. So right here we see that we have two exponential expressions that are being multiplied together. So again, the way we handle these numbers in front is just like you normally would. Treat those, don't do anything different. 2 times 4 gives us 8. So we get an 8 that comes from those two numbers. Looking at k to the fourth and k, this goes back to our first exponents property that we learned of. And what that said is that anytime you have two things that have the same base, our base is k here, what we need to do is add the exponents. Now, if you notice, one of those k's doesn't have an exponent. And the reason that is because there's only one k on that stack. So we can put a little 1 there to hold it if we'd like. But if I have 4 k's on this stack, and I have 1 k on this stack, when I put those two stacks together, we're going to have 5 on the same pile. So I will have 8k to the fifth. Let's look at the problem below that. In this problem, again, we see that we have parentheses. If you remember back to the last video, we were talking about PMME. Parentheses, mean, multiply, exponents. When you see parentheses, that is a telltale sign that you are going to be multiplying exponents together. Now, before you can just jump in and get going, you got to make sure everything inside the parentheses there has an exponent. The k has an exponent, but the 3 does not. So we're going to give the 3 an exponent of 1. And that part, ladies and gentlemen, is the hardest piece for kids to remember. You've got to remember that 1, otherwise you're not going to get the right answer here. So we're going to multiply the exponents. So we'll have 1 times 4 will be the exponent on the 3. And on the k, we're going to have 4 times 4 will be our final exponent. Now we can just simplify a little bit. 1 times 4 is just 4. And 4 times 4 is, of course, 16. So we get 3 to the fourth, k to the 16th. Now, we should go a little bit further with this, right? If you have your calculator, you can pull that out. That might help us out. 3 to the fourth, right? That just means take 3 times 3 times 3 times 3. So we'll get 81. And then we don't know what k is, so we can't do the same trick there. But do remember, ladies and gentlemen, you should be able to type this in a little quicker, too, if you use your caret key. My caret key is right above my division symbol. It's that little up arrow there. Once you hit that, then you should be able to type in your exponent, and that should evaluate it for you. Right? That's just a little refresher to RE1. So again, here's our final answer. Let's put a box around that so that you can find it easily. Let's move on to the next problem. We'll do the one right below it again. We're just working down the list there. In this problem, we see that we have 3n to the fourth over 3n to the third. The way we've been solving these thus far is just to sit there and string it out. So we would n to the fourth just means 4 n's multiplied together. On the bottom, n to the third just means n, n, n. And then the trick we learned yesterday is that if I have the same thing on the top and on the bottom, they just cancel. Did I get them all? In this case, no. Did you notice that we have a 3 on top and a 3 on the bottom? Those two can cancel off as well. So what am I left with? I'm just left with n on the top, and then to hold the fraction, we put a 1 underneath it. Now we know that anything divided by 1 is just itself, so this is the same thing as just writing n. Nice job. That one simplified really nice. Let's go to the next one. This looks like a big one. Let's take this kind of slowly here for a minute. When we look at this problem, ladies and gentlemen, let's start by just stringing it out. So m to the fourth just means m, 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 m. n to the third just means n, n, n. And p to the third just means p, p, p. Underneath that, the 3 is just going to sit out front. And then we have m to the second, so 2 m's. We have n to the second, 2 n's. And we have p to the fourth. From there, we can cancel anything that there's the same on the top and on the bottom. So we can cancel an m and an m, and we can do the same right there. We can cancel an n and another n, and then we can actually cancel 3 p's. From there, all we're doing is we're just regrouping up our terms. So we're still going to have a 4 sitting out front, and then we had 2 m's. So we can rewrite that as m squared. And don't forget about the n that was sitting over there. Now on the bottom, we had the 3 that came from the very front there. And we also had this 1 p over here that didn't get canceled. And we're done. That's all the farther we can go with this, ladies and gentlemen. Sometimes these two numbers will make a fraction that can be reduced. Obviously, we can't reduce 4 and 3 right now. There's no common number that divides into them. So we can't go any further with this one, but just something to watch for in the future. Here's another problem for you. This one's a little unique. Now, if you notice, in this one, this is something we haven't seen before. We have x's over here, and we have x's over here. And the way they're connected is by this multiplication that's happening in the middle. Now, exponent problems are much easier to work if you get these two stacks on the same pile to begin with. So if I were to put those two on the same pile, right, this stack had 3, this stack also had 3, then I would have 6 altogether. So we can rewrite this as x to the 6th, and then everything else is going to stay the same. We're still going to have a y to the 3rd up top, and then we're going to have a 4x to the 2nd on the bottom. Now the way we've been working this, folks, is just to come over here and to expand. Once we have everything expanded out, then we look for common terms that are going to cancel out. So it looks like I cancel. It looks like I'm still left with, looks like 3, but don't forget about this x, 4 x's total on the top. It looks like I still have 3 y's up top. And on the bottom, I just have the 4, making this our final answer. Well, that was cool. Moving on. This might be our last problem. Last problem for our part 2 video. All right, looking at this problem, we see again that we have parentheses, but notice inside how I kind of have 2 stacks of n's happening at the same time. So just like before, let's try to put those 2 on the same pile right now to start. Our first pile had 4 of them over here, and this pile only had 1. If I put those on the same pile, I will have n to the 5th, right? And the reason I can do that is because they're being multiplied. Now I'm still going to have the 4 here, and we haven't dealt with the 2 on the outside, so I still have parentheses with the 2 on the outside. Now would be a good time to use that PMME strategy. Remember, parentheses mean multiply exponents. That's what PMME stands for. So the first part of the PMME process is you got to make sure everything inside the parentheses has an exponent. So we added in that little 1. Now we can come over and multiply. Remember, the base does not ever change. So now I'm going to have 4 to the 1 times 2 power. When I multiply those together, I'm going to get 2. And then I'm going to have n, 2 times 5 is 10. Last part of this, I hope you're seeing it too, 4 to the 2nd. We could simplify that if we wanted to. We might not always see it simplified, but sometimes we will. So 4 to the 2nd means 4 times 4, which is, of course, 16. And then n to the 10th will be as good as that gets. And that's it, kids. Part 2 of the video. If you have any questions, please be sure to email your teacher. We are here to help. Thanks for watching.